For activity 2, we will use the same circuit as activity 1. The only difference is we changed this to an AC voltage source, which means we're using sinusoid waveform right now. So what we are doing here is we change the frequency of our AC voltage source and measure the voltage across the capacitor and see how the frequency will affect the voltage across the capacitor here. So hopefully we'll see under low frequency, we will get almost the same voltage here, but under high frequency, the signal will be filtered out and we will measure almost nothing or almost zero here. So for your task or for the task of these activities, we first need to derive a equation, like the relationship between the input voltage and the voltage across the capacitor. We already talked about this in the lecture video. So it's basically this stuff. And then you need to calculate the cutoff frequency of the circuit here, and then plug in the cutoff frequency to the equation we derived here, and see what is the input-output relationship at the cutoff frequency here. And for this table, we will be testing 3 different frequencies. So the cutoff frequency, and the frequency which is a decade lower and a decade higher, and you also need to calculate the corresponding digital frequency, and then you plug in those things into your derived equation here to find out the capacitor voltage under the different frequency. So here we already measured and simulated those capacitor voltage under this frequency here, and you can use this value to verify your calculated value. So here I'm going to show you how to do the simulation for activity 2. So the circuit we're using is the same as activity 1. I just replaced the source voltage to AC voltage, or to the sinusoid signal. So I hide the parameter for this voltage source because you need to calculate the frequency of this voltage source by yourself. So, but we know this voltage source is 10 volts. It has 10 volts peak-to-peak voltage, and I think currently the frequency is set to the omega c, to the cutoff frequency of this circuit. So what we want to do is to measure the voltage across the capacitor, and you see this probe here. It will automatically show you the peak-to-peak voltage in this small window here. So if we run the simulation, let's see, this is the output voltage, the capacitor voltage we measured at the cutoff frequency here, and for other frequencies, for like 1 decade lower and 1 decade higher, we just change the frequency from the source voltage and run the simulation again to record the peak-to-peak voltage here. For the measurements in the real circuit, I won't show you in the videos because the oscilloscope will automatically show everything, including the frequency value I want to hide from you automatically. So I can't do it in the video, but I can do it here in the simulation to give you a feeling how you measure this value in a real circuit. So basically, if you measure the voltage across the capacitor using oscilloscope, and on the oscilloscope you will visualize something that looks like this. I'll change the simulation to transient simulation, and already putting the input, so the output is already defined as the capacitor voltage and the source voltage. So if we're doing this on a real circuit, we will visualize something like this. So the green line is the input voltage, and the red one is the output, the capacitor voltage. So as you can see, the output is already being attenuated for a little, but we were still getting almost the same shape, almost the same voltage input here. So what we're looking at, if we're doing this in a real circuit, we want to look at the peak-to-peak voltage, which is the voltage difference between this peak to this peak. Sorry, I think it should be for the red one. Between this peak, like difference between this peak and this peak. So again, we need to use cursor. So we put one cursor at the one peak, another cursor at the second peak. So if we look at the differences in voltage or in Y, you see the dy here is about 7.48. So this is the peak-to-peak voltage we're looking for if we're doing this in real circuit using oscilloscope.